Each device needs to communicate with other things around it to meet the needs of its users. Welcome to a new video where we're going to talk about this is a new age paper. So we're going to analyze it, we're going to read about it, and of course we're going to share our thoughts and opinions on this new video. And I wanted to start with this phrase because I think it is important. People start talking to their phone, doing things nearby their phones, scrolling on their cell phones, and suddenly your phone knows a lot about you. It starts targeting the correct ads for you, correct communities, accounts, places, and others. And for some people, this is terrifying. But this is how the Internet of Things starts appearing in the picture. We have a large population volume that start being connected with objects around them to improve their quality of life by sending and receiving various services. The number of objects was estimated to be around 75 billion in 2025, much more than the human population back in those days. This rapid and dramatic growth has caused problems such as scalability and feasibility. Therefore, different communication types between objects are necessary for our daily life demands, regardless of their kind. Each object that is considered a friend of another object must have different parameters, such as scalability, interoperability, and trustworthiness to form a healthy relationship or friendship based on evaluating these factors. Therefore, each object can communicate with other objects to improve the interaction between humans and objects based on a set of rules defined by their owners, such as how objects communicate, choose a friend, and provide services. Each device we use soon becomes intelligent and social, and with the help of better sensors can receive or send information. Socialized objects provide more accurate and faster responses to complicated requests than objects that work individually. Hence, we can conclude that the smarter things become, the more social the IoT becomes, or the Internet of Things becomes. The social network of objects is modeled on human beings, shape on us, based on social behavior so that they communicate with each other and form their social network as well. We were talking about the previous videos, how we try to emulate our various qualities or characteristics into external devices or machines in order for them to start integrating the intelligence and also to start memorizing, doing mimics, and things that can actually resemble a human being, but in better phases because they only take the best of us and replicate it. So how humans communicate with each other is the key to creating a social network of objects as well. But what about the elementary relational models based on human communications? We have communal sharing, and it's for people who belong to a particular community, such as family and friends, to communicate based on the shared profile of the information they need or offer. We also have equality matching, based on the similar connections between different members of a particular group, while retaining their own identity and keep it load balanced in the data change in the involved objects. There must be a balance between requesting and providing a specific service. You also have authority ranking, where humans are classified hierarchically according to different levels and with different complexity. Each human being has access to a level based on his score, which leads to their asymmetric categorization. So anyone with a lower rank should be a service provider to someone with a higher score. Finally, market pricing. Communication between people is based on common benefits and social privileges, such as wages, prices, and values. And what about web services? Service discovery is the process of searching for objects that can provide the desired service. Selection is a selection process of appropriate service match to requested services. Service composition is the process for combining different services to offer an appropriate response to requested services, which results in the desired quality of services, better functionalities, and feasibility because a service cannot meet all users' needs. So, choosing suitable services and a combination of them can be one of the main concerns of this environment. We can also present the IoT Big Data as a four-tier framework that includes a collector server to collect the sensed data from a common community of objects into our environment. B, a storage server to store different types of data that are aggregated from various devices. C, a filtering server is a primary processing unit to remove noisy data from raw data, then send it to the process server to accomplish these interactions. And D, a process server to analyze and process stored data. But what are the most important challenges of the SIoT, which can be understood as social Internet of Things or subsea Internet of Things? And we have heterogeneity. This is made up of millions of objects, the SIoT, with different features in sources, platforms, protocols, and standards. And all objects and data must be recoverable. These differences have led to the creation of a heterogeneous network of objects that affect their interaction and capability directly with each other and increase complexity, so that the heterogeneity nature of objects leads to many important problems like interoperability and compatibility that need solutions to solve them. Another challenge will be mobility and dynamicity. Smart objects placed in a dynamic environment are constantly changing their location, which leads to problems such as a lack of effective object search for selected and provided services. The other important issue is the dynamic behavior of objects and environments, which leads to a change in the state of objects. So the objects alter their status in the network. Some solutions proposed for these issues, such as creating objects communities for solving mobility. Groups of objects can be formed into communities based on distinct features like their movement, social behaviors, social similarities, and common interests to interact with each other. When an object changes its position, the structure of the community alters based on this displacement. Therefore, we can use some functions like Euclidean adjustment matrix or global positioning systems to get the current location of objects for calculating their distances. We also have another solution such as manage dynamic behavior of objects. For solving this issue, objects needs to dedicate some main rules and protocols by their owners to manage these changes to prevent from changing the network topology. Although adaptability is the other issue that arises from this dynamic, because an object needs to adapt itself with these freaking changes. Tracking objects, one of the main issues of SIoT would be tracking objects, interactions, and activities. We also have security, trust, and privacy because of a huge connected environment of devices, opportunistic services, and users in SIoT. Security is an essential key to share information guardedly. So, contrary to many types of research that have been done in this field, it remains as one of the significant challenges and requires handling for the survival of the system in the face of various attacks to have security, reliability, availability, resiliency, and interactions. So there is some solutions to the problem as well, such as accessing control systems. We need control systems to prevent unauthorized access to data, effective encryptation mechanisms. They can also use an effective encryptation mechanism to encrypt data reliably or use cost effective and self synchronizing models to secure real identities from attacks. Trust management framework. Moreover, we can work on the SIoT Trust Management Framework to provide new applications for making trust between objects and users. Safe data sharing model. We can also create privacy preserving user and object communities based on policies to for a dynamic and safe data sharing model for more security and privacy. Predicting node behaviors, we can use some techniques like machine learning and decision tree for predicting nodes behaviors. Another problem will be resource constrained devices. Even though the IoT is a system with limited resources, and this issue has a direct impact on the life of the network and the exchange of information, there's still no optimal solution to address this issue, but considering energy limitations at all levels of design to have more effective interactions. Therefore, we need more studies and research to create an effective resource management system on the IoT to get the most out of such a system. Efficient service search and discovery. The large number of objects in SIoT led to lower scalability and navigability for selecting friendships, searching services, and making an appropriate connection between objects. This issue increases the overhead at all levels of the SIoT system. So, one of the main issues is effective search and discovery of the services, which leads to a reduction in system overhead, provision of services with greater efficiency, better response time, decrease updates transactions time, and increase the navigability and scalability of the network. So there are some solutions to this problem, such as using a mechanisms to control overhead. We need a mechanisms to control overhead and effectively search for services and resources, such as creating communities of objects based on main parameters, such as social similarities, providing similar services, resources, and other similarity measurements, and using new searching algorithms. There can be used intra-community and inter-community service search algorithms between detected local and global communities to discover services efficiently. The objective is also to discover the IoT ecosystem, which includes six subcategories: architecture, relation management, trust management, web service, process, related information, and tools that consist on platform and dataset. And showing the elements one by one, we also need to further explore these items in order for us to have like a wider picture about what is SIoT. For some people, perhaps this is the first time they hear these four letters together, because the most common one will be the Internet of Things. But now we have the IoT, which I already defined what it is in this video for. So we start using this set of integrations, algorithms, devices, being part of big data, and we don't even know the consistency of all of this. We are just another number of people tend to mention, but this is an entire machine. This is a system. So if it is a system, it consists on mechanisms that works every day, but each mechanism also has its own issues. I yes also recall here a few of them because there are like a lot more. Don't you find curious that we tend to be including into these things we have without having the full picture of it? That's basically it. We just assume we're part of a network, but we don't know how big this network is and how companies need to delimitate all of this because internally they know this, but externally we are just posting pictures and talking with the strangers online. We are just connecting with our family members on different apps, or we are just playing video games in some kind of platform. We just bought one video game and started like playing it without even knowing that. Yeah, for that you had to give consent to cookies. For that you needed to give some information, and then their machine starts acting with just one numbers as we tend to think. It's good to have like a wider picture of this because I know some of us we are experts, we are dedicated, we haven't studied all of this, but as long as we know like few parts, we can start limiting our own concerns, our own pictures on the web, and our own expectations or few expectations every time that we enter a new platforms, every time that we share something. This might feel like, oh, there's a lot of things that I don't know, and I might feel like insecure. And is it okay for me to start posting everything? Or today I was going to post a story on Instagram, or I was going to sign up for a newsletter. What do I do now? Just keep looking, keep searching. If you arrived to this video, it's because the intrigue is already turned on. So just keep going and of course, try to share in your community things that could be complementary to this one. Because I have to dig to sit and dig into what's going on with this and trying to read to you, to share my thoughts alongside, and to raise questions for you to start digging more and for also for you to contribute to this community and for me to keep digging more based on what you shared to me as well. Because we were already joining the community digitally several years ago without even knowing what was I contemplating. And companies didn't even know either because this started like rising like pretty fast because of the demand. Without the demand, there would have been all of this and the companies wouldn't have the need to being up to date with everything technologically speaking. We also talk in another video about the factory level. Also in factories, how what do they do with their workers? How do they manage to keep their workers up to date? And the relationship between having a factory in the newest industrial revolution up to date, being behind, or just like right in the middle. And what's the relationship with the current human workers in there? So this just covers all surfaces. It's not only me or you having a phone, is something way bigger than that. And even companies don't know what to do or what's this all about. This high approach and high demand wasn't expected to increase so rapidly. And there are so many people nowadays connected that we just assume that we need to be connected because we need to be connected. If not, we are going to be out of society. So now being digitally connected has been converting into need in order for us to be part of a community and to tap into a society that demands from us more than expected. Thank you so much for being here.